Hello and welcome to Module 3 in Big Data Technologies. I'm kind of running through these a little quicker. I plan to circle back based upon either any questions that come in or once I get through all the modules, I'll circle back and start working through them again. So jumping straight in to the module overview, what's the point? And the basic centered topic inside of Module 3 is around SQL-based solutions. As you know, SQL is a very popular language for querying data sources. And a good example of it is Hive in the big data world. What I'll be showing you later on is sort of Hive. I'm going to look at it from a different sort of angle. Databricks is what I'll be demonstrating, and Databricks is essentially combining together several open source projects, including Hive, Spark, Delta, and a few other things to make what is they package as Databricks. So we'll be going through that in a moment. So the basic idea here, though, is that the idea is to enable people to do big data workloads without necessarily having to learn something new, like a new programming language. If you were going to do work inside of MapReduce originally, you had to know how to write Java code. Hive came along and basically allowed you to do queries that were then interpreted and converted into MapReduce jobs, so it made things a lot more approachable. That enables it to be used in things like a data warehouse sort of workload. So the idea is that where you might traditionally be using a data warehouse, you can then use something like Hive instead. And it's also a good way of doing experimentation exploration, so you can quickly take a look at data, learn something about it, and then potentially you might do something more productionalized on it after that. And it is an easy way to get started with big data technologies. You can think of it as a gateway technology because it is so accessible. You basically just need to know how to do things like a select from various tables, and you can get up and running. So very, very approachable, and that's part of what has made it pretty popular. So in this module, you're going to learn a lot about SQL-based solutions and how they can be applied using something like Apache Hive. You should be able at the end of this experience talk about SQL query construction in a Hive environment. And big surprise here, it's not all that different than what you might already know. And then talk a bit about the support, the use of Hive to query, summarize, explore, and analyze heterogeneous data. So one of the things that is useful with things like Hive is it allows you to interact with data that goes beyond traditional relational data. And then also there's this concept of PIG and PIG Latin, which is used to similarly provide a layer of abstraction that produces MapReduce jobs. So one of the things you'll hear is SERDI, right? And that's really nothing more than serialize and deserialize. The reason it matters is because whenever you store things to a file system, they need to be stored in a certain type of format. And that's what the serializers and deserializers do, is they convert data from something that can be used in memory to something that can be written to a file. So Hive uses them along with the file format in order to basically store the data that you're querying. HDFS files are then kind of basically you go through this sort of a format, so it might be something that is essentially key value or whatever. You run a deserializer and that turns them into row level. Likewise, you've got a row object that you've got in memory that you're working on, and you want to serialize that into something that is essentially name value pairs, and then you want to put that into some sort of an output format, and that gets stored inside of HDFS. So it's basically a way of, think of it as a secret decoder ring that you use to encode a secret message that you then store to the file system. Then you use it to decode that message to be able to interact with it. And that's not to say that it's encryption in any form, it's just basically an analogy. So there's various types of SERDE out there. You can write your own if you were so inclined. I wouldn't recommend it, but you could. JSON SERDE is, as the name would imply, lets you read and write JSON files. Avero is another one that's essentially the same thing with Avero files, and Parquet is natively supported in Hive since 0.13. and Parquet is a very popular sort of columnar format of files, and CSV has been available in Hive since 0.14. So these are kind of out of the box, plus you can always add your own. So HiveQL, you have this concept of a CLI, so a command line interface. And since people that work inside of Hadoop and open source packages like to have clever names, it couldn't just be the Hive CLI, it's got to be Beeline, right? So it is a way of letting you run commands at a console, get back results. There's also inside of Hive the typical sort of format for data types that you would expect, a numeric, date, time, string, etc. You also have a data definition language that allows you to do things like create databases, create tables, create in views, and drop them and so on, alter them. An index, which is available to you in Hive, that's not necessarily going to be in something we show you today, or I show you today, but it is, the concept can exist inside of Hive. You also have a create and drop of a macro. What I will be showing has something very similar called a user-defined functions, essentially a macro. So HiveQL does support the typical data manipulation that you would expect. You can do things like load data into a table. You can insert data from tables from queries. So you can do essentially select insert into table blah from a select that is essentially a nested subquery. You can update and delete from Hive 0.14 on. You can merge into from one table to another, so you can do something like a merge on and give it a condition and then specify what should happen in the case things match, things are being deleted or things are being inserted. And so for more on that, you can certainly take a look at the language manual for DML. The most common query you're going to use is going to be a select, and that's where you basically are going to be doing things like group by sorting, distribute, order by. You may do some transformation. You can also do operators and UDFs, so user-defined functions, joins, unions. These are kind of typical things that you'll typically do inside of most databases, and Hive supports it, including things like subqueries. Here's a Hive cheat sheet for creating a database in both MySQL and being able to do things like show that database and so on. So at that point, I'm going to shift over to the scary part of the presentation, which is a live demo. So this is Databricks Community Edition, and basically what this allows you to do is have a entry-level sort of experience with Databricks, and Databricks is nothing more than a combination of open source packages, including Spark and Hive, to allow you to do data exploration, machine learning, data engineering, and so on. I'll start off here by creating a notebook. I'm going to just have a queries notebook, and I can specify that I want it to be SQL, and that's really a Spark SQL, which is kind of a variant of Hive SQL. And so we can start off with using my cheat sheet here. Let's do a show databases and see if this works. Okay, and so it's submitting the command, and there's only one database here, and that happens to be named default. You can also see that by going into the data tab here, and it'll show you the same sort of thing in a UI sort of fashion. But again, we're just doing this using the equivalent of Hive commands, so we can say use database if we had more than one. If we don't have more than one, there's really no point in doing a use. And a use is basically making it the active database. You might also want to do a show tables, right? So what tables exist in this database? And we can see there's only one because I just created it. But we can do a describe, and then train one CSV. And it to tell us what there is about it. Not very meaningful because I didn't do something I should have done, which was tell it to treat the first row as the column name. And we'll go through the process here in a moment to show how that works. The last one here is create database, and we'll call it Titanic Not that I can spell, but it doesn't matter. So now if I go back up here and I say show databases, I'll have more than one. I should have Titanic. And I can also now be able to say use and that'll make it my default database. So now going back and I'll show the process of doing an import of data. So I'm going to go over here to a training set, our good friend Titanic, and I'm going to upload by dropping onto this little box. All I did was drag a CSV over and then it's basically uploading it. For this case, I'm going to just say create it with the UI. I got to tell it what cluster, and I've only got one because you're only allowed to have one inside of this environment. I'm going to call this test because that's really what it is. I'm going to create it over in Titanic. It is a CSV, and the first row is the header. So I'm going to switch that so it now knows that the first row is the header in the file. And I'm also going to tell it to infer schema. So that means it's going to try to figure out the data type based upon the values that are present. And so that's as good as any for this. And you can tell that it's doing, some of these are strings because they do have some other data in them. And with that, I can say create table. And this is actually doing the equivalent of create table. Hopefully my cluster didn't just go away. All right, let's see if it's still running. It's still running. So we'll do it the other way. Let's double check and make sure it didn't actually do it. Oh, it actually did. Let's see if the data is actually in here. So what I'm doing is the UI, and it can basically, looks like it worked fine, just gave me a weird error. So 418 sounds about right. So now we can go back into our queries table, and so we could go through again, show databases, and then I'm going to move this guy up. One more. To use Titanic, then show the tables. And we can see there is a table named test. And then we can say describe test. And it should have meaningful column names, not those cryptic ones that were just being automatically issued. And notice the data types. You can also have comments in here. So you can do an alter table and add comments, which is probably a good best practice. So we can also do now some of the typical sort of things. So select star from Titanic, limit 10, just so we only get the first 10 or so. Did I misspell it? All right. Oh, that helps. Test. It's going out and just randomly grabbing 10 records. In this case, because Spark is running inside of a single node cluster, not nearly as interesting as it might be otherwise, and performance obviously would be listed. So you can also do, okay, so going back to kind of our presentation, we've worked through kind of these, the Hive commands. Let's take a look at some of these other ones. So some typical ones here. So select where there's some criteria. So select star from test where age is greater than 18. So maybe we want the adults. And it's going to only return a certain number. So in this case, it 278. If there had been more than 1,000, you only see the first 1,000. That's one of the things it kind of does to help you from hurting yourself. All values, kind of a common pattern you might do, typically not the best idea. And if you wanted to check where, you can also do something like select star from test where name. You can do the equals, or you can also say like %Kelly %. And we get James Kelly. might be more interesting to do it where it's like James, right? Because that would give us both I guess the first names, and if there happened to be somebody with the last name James. You can do obviously the composites, so we can take that and age greater than 18, if there are any. And well, they all are. So let's a little see if there's anybody less than. Or equal. It must be 18. Interesting. So, but you can combine together composite sort of logic. You can do a particular column. So just a projection of a single column. And you can do the same thing with distinct. So very, very similar to the MySQL sort of dialect. In fact, you'll find that most of the time it's pretty much, even to the point of the limit clause is similar as well. That's it doesn't use the top sort of syntax that you might have in TSQL. Instead, it uses the limit clause on the end, which is much more of like MySQL. And then the typical sorting. So you can do actually probably name would be more interesting, right? So what was it? Name from test order by name. And you'll notice it's not case sensitive, as SQL shouldn't be. And the same thing would be true of descending if you wanted it in reverse order. We usually do select count from test. So we can do the normal sort of aggregation that you would do. You can also do the group bys. So select p class comma count from test group by p class. And you could even and do the aliases as well if you're so inclined. So we can do as something, and then you can also have having count greater than 100. So we can filter with typical grouping. Your additional select max of age. And then and there's also max you can see the traditional sort of descriptive statistics. One of the things that you can also do is joins and unions, just as you could with any other environment. So to show kind of that in motion, we'll go up here and import. Oh, this time I'll make it so you can actually see what I'm doing, assuming my computer cooperates. I've got a little weirdness going on. I believe this to be a Windows 11 bug that I haven't quite got reconciled. So give it one moment. So I'm going to do train and drop it onto here. and then create with UI. It's already on my single cluster. We'll call it again just train. Put it in Titanic. The first row is a header. You can see you can also specify delimiter, so you could actually handle pipe delimited, tab delimited, and so on. And we do want to infer schema. And then we'll say create the table. This time we didn't get the weird sort of error, but it does give you again kind of the sample of the data that's comes in, the first few rows. So going back to our notebook, if we go back up here now and say show the tables, we should also see train. So you can do the typical, scroll down here to the bottom, select star from test union train, and I believe that's the syntax. Of course not. Union, maybe it's this. Okay. Maybe the columns are probably different. Like one of them is going to have survived or not. All right, well, this is when we always go off the script, and this is what happens. So we can do the set operators, and our good friend Stack Overflow is tempting, but we'll go straight to the docs instead. It probably wants the parens. You can see that tells you when you mess up. There we go. So now we see the union of all the names, and again, this is telling you that it's only showing you the first 1,000. So that's union. It's kind of getting at the edge of what we normally would want to do here. There's not something we can really join on because there shouldn't be a relationship between these two tables. So, but we should be able, hopefully, to do this. Let's see what happens. Nope. Would have to do some sort of a different sort of join. So some of the slight differences than what some of the languages you might have dealt with. So with that, going back, I'm taking a look at the cheat sheet to see if there's anything else here to run through. I think we've done most of them. A key thing that's interesting is that your tables can include inside of them more interesting data types, such as JSON documents, essentially, or internally it's actually going to be more of a map object. So you can actually use dot notation to select inside of a column that has something inside of it that's a more complex type. So a very powerful sort of environment. Moving on to the deliverable for this unit, deliverable 3. So you're asked to, or you're going to be dealing with developing an SQL-based solution that can be applied against Apache Hive. So as always, take a look at the rubric to see how it's going to be graded. You work at Big Data Connection Inc., DBCI, still have that job, as an international, it is an international data clearinghouse that provides data services to thousands of customers. You're a data scientist there, and you're expected to work with Hive on HiveQL on a regular basis and understand its many nuances. For professional development purposes, you have been given the assignment of developing an SQL-like command line queries, so queries that you would run to analyze large amounts of data. You will need to be to perform various command-like statements using HiveQL to become familiar with its various idiosyncrasies. So write a report to your manager to review that includes the following. Provide the command line for creating a database using HiveQL. Include a comment location parameters and indicate the use of the properties. So the location as to where it should be stored and so on. I didn't do that in my example, but you could. So you just say location inside of that command. Provide a HiveQL command line for dropping a database. Hint the names in the instruction. Provide HiveQL command line for altering a database. So again, the hints in the statement. Alter would be a good place to look. What is the HiveQL command for using a database? Again, kind of giving it away. What is the simple HiveQL command for creating a table? What is the default table type created by HiveQL? That's a little more specific than what I've just shown you, so you have to do a little bit of research into HiveQL. What are the 10 different storage formats supported by HiveQL? What is the shortened name for using HiveQL commands? Command lines for serialize and deserialize. What is serialize and deserialize used for? What are the 3 main components of HiveQL? As always, a little bit of a hint here as far as the place to go look for the DDL and also the developer's guide. And the rubric, as always, you'll shoot for that far left column. A thorough and detailed paper has been developed with an explanation describing the command line for creating a database using HiveQL and the location. The paper provides the HiveQL command line for dropping a database, altering a database set, and using a database. There was no errors in your paper. Provide an explanation describing the command line for creating a table with information on the default table type created by HiveQL and the 10 different storage formats supported by HiveQL. The paper is basically free of errors. Provide a thorough explanation describing the shortened name used in HiveQL command line for serialize and deserialize, its use, when to use the serde command, and the 3 main components of HiveQL. The paper's free of errors. And with that, I'll go ahead and pause for a moment to think about trying something crazy. Let's see if I have my terminal up. I don't. So let's see if we happen to have Hive inside of the Hadoop that we created the last time. And if not, I may tackle that. So if you recall, we put it in Ubuntu 18. And let's take a look here. Let's just try the obvious. So Hive is not found. Hadoop Hive. So Hive is not found. So probably I need to actually install Hive. Just taking a quick look, something I probably should have looked at ahead of time, but just to see if it's simple. It looks like it's something for a future sort of walkthrough. To give a bit of a heads up on what I'll probably be talking about, I took a look here of, well, what do you do to install Hive in Ubuntu? And again, my computer is doing really interesting things. And it looks like you start off by basically doing the download of the various version that you need. Then install it. I'll do some editing. I'll try to work this in our Wednesday session, because I think it could be quite relevant to have an environment to do this in that doesn't involve having to spin up a cluster. And with that, I think I'll go ahead and close this out. So as always, if you have any questions, let me know. That's what I'm here for. If there's something you want me to talk about, let me know. I'll be glad to talk about any of the topics that might be interesting. Stay safe, and we'll talk again soon.